Question 24 from the 2022 National 5 Physics exam from the SQA, taken from section 1. A radioactive substance is to be injected into a patient so that blood can be monitored using a detector. It doesn't tell you what the detector is, but with a good guess it's going to be gamma detector. A number of different substances which emit either beta or gamma radiation are available. The substances have different half-lives. I'm being asked to find which row in the table identifies the radiation emitted and the half-life of the most suitable substance. Well, it has to be gamma, because if you're injected with any other radiation like alpha, beta, alpha is very dangerous, very ionising, and it won't pass through your body, so it will not be detected. Beta radiation as well, that will not be detected because it can't get through your skin as well. So alpha and beta are out. So what we're looking for is the radiation emitted must be gamma radiation. Now, the next problem is, what will be the half-life of it? We want the half-life to reduce the activity of this inside the body as quickly as you can, but still give you enough time to do the examination. So obviously 2 years is out, so response E would be definitely out for that one. So we can, response E is out for that. A is out, and so is B out, because they're both beta and beta. So we've got between C and D, and we have to have 2 seconds would be just too short of a half-life, because you wouldn't have a lot of activity to detect maybe after the course of maybe waiting for about an hour or 2 hours after being injected in some hospitals. So the 2 seconds one is out. So that leaves us with gamma rays with a half-life of 2 days, which means over the course of maybe say 20 days, a fortnight, or maybe a month, the activity has been substantially reduced inside the body, which makes it less riskier. So answer to question 24 is D, gamma and 2 days. Question 25 from the 2022 National 5 Physics examination from the SQA, the last question in section 1. Rhodium-106 has a half-life of 30 seconds. A sample of rhodium-106 has an activity of 3,200 becquerels. The activity of this sample after 120 seconds is, and we're given our usual responses. So the first thing we have to do is find out how many half-lives are going to be in 120 seconds. We know one half-life is 30 seconds, so in 120 seconds we're going to have the following half-lives. So the number of half-lives will be 120 divided by what one half-life is, 30 seconds. So we're going to have 4 half-lives in this given time. So 4 half-lives will be there in 120 seconds. So our starting activity is going to be 3,200 becquerels. And therefore 1 half-life later is going to reduce by half to give you 1,600 becquerels. Then the second half-life is going to be 800 becquerels. And the third half-life is going to be 400 becquerels, and finally the fourth half-life is going to have to give you 200 becquerels. So we're looking for an answer of 200 becquerels, and that's going to be the answer C, which is going to be the correct answer for 25.